Good morning. So today I'm going to talk about the Great Fire of 2021. And for a lot of people, that means March 10th, 2021, when OVH had a huge data center fire. For me, it started at almost 4 o'clock in the morning when one of our OnCall engineers called me because he was in real trouble. Actually, the first time the phone rang, I didn't realize the phone was ringing, and I pushed it off again. And then 2 minutes later, he called me again. And while I was waking up, he said, "Our data center is on fire." And when you get that call, you start thinking like, wait, what? What did he just say? What just happened? You kind of get a partial panic attack in the sense of it can't be that bad. So I was heading downstairs and I was starting to realize like what is really going on. And by the time I was downstairs, I found this tweet. This was the public announcement that there was a real major incident in Strasbourg where there was a fire in the building, and that not only the data center that was impacted was down, but that the fire services had decided to also power down the rest of that campus. And the fine line was, well, basically it's time to activate your disaster recovery plan. And the rest of this talk is going to be about those actions. So you can learn from what we did that night. My name is Kris. I used to be a developer, became an operations guy, and for the past 15 years I've been talking about automation, about infrastructure as code, about surviving the 10th floor test. And actually this is a talk where all of that experience, all of the things we've been talking about came to be reality. If you look at the public impact, according to Netcraft, there was 3.6 million websites across 460,000 different domains being impacted. That sounds huge, and for a lot of people, this really was huge. For us, obviously there was impact, but it wasn't huge. We survived this thing. Our immediate assessment at 4 o'clock in the morning was which customer-facing production services have we lost in this? And then after that, what internal production services have we lost? And do we need to recover any of those in order to recover the production services? We were looking at priorities, like which services are actually supposed to be 24/7 generating platforms? Which services are actually tools that are only being used during office hours? And what parts of these services can we restore? What part of services have been restored already? And it actually was not that bad. Our immediate visible part was that most of our customers had automatically failed over to a secondary data center. There was one platform where the failover of the public IP address had failed. There was another customer which actually had their whole stack spread over 2 physical data centers, but that was Strasbourg 1 and Strasbourg 2. So they were completely offline. And then we also had one customer where actually that data center was the disaster recovery site. So that disaster recovery site was partially destroyed. So the failing VIP was one we needed to tackle because that was business impacting. It was pretty much the API call to the OVH instances to tell us like, move that IP address to another service. And what we did at that point was manually change the DNS of the incoming traffic and use the public IP address that we still had available, that we could use the public IP address of one of the load balancers to do that. For those who know me, you realize that this is when you end up having a DNS problem, because that stack was kind of fully under our control, except for one domain that customer was using. And that's where we lost most of the time. We lost about 60 minutes because we could not update the DNS, and we couldn't reach anybody who could update the DNS. And by the time they eventually had updated the DNS, over an hour got lost. The secondary part there was that some customer devices that were talking to that IoT stack still had hard-coded IP addresses because the devices that were talking to it had no other option. So there we needed to do some manual interventions. So that was one of the first technical problems. The second problem was a platform that didn't have any redundancy in a different campus. So what we decided there is we're going to rebootstrap this stack and we're going to spin this up again in a different data center at a different supplier. We still had spare hardware around, so we could do that. And because we had everything fully automated, we could restore the most recent backup, which was kind of 2 hours old. And as this is a platform that was only used mostly during daytime, that was the exact data we needed. We could rebootstrap that completely from scratch and be up and running again before 9 a.m. on the Wednesday morning. At 9 a.m., the thing we were still trying to improve was the actual performance of the platform. But if we wouldn't have told the customer that their whole data center, their whole stack was gone up in fire, they wouldn't have noticed it. Obviously, the problem we were facing there was an MTU problem between the load balancers and the database and web servers. It's not always a DNS problem. Sometimes it is an MTU problem. So what was our impact? During that night, we lost 13 physical servers. We lost about 135 VMs. The root cause of that outage was potentially that there was a UPS maintenance. So was that something that could have been prevented? Probably. So customer facing, we really didn't have that many problems. Internally, we had a couple of stacks that we needed to respin, that we needed to restore, but pretty much all of those were automated. A lot of our test infrastructure was gone because that's not spread over multiple data centers. A couple of our development environments were gone, but we can all spin them up again. And also, at 6 a.m. in the morning, you joke about, hey, why is half of my Q cluster gone? And Boo was joking about destroying Kubernetes with fire because, If you look at that night, there was the OnCall engineer and me. We didn't actually escalate further to more people because we had most of what we needed to recover under control. Spinning up everything again was about 18 hours of work, mostly coordinating what needed to be spun up, what was ready already, talking to end users, let them verify if things were actually working again. But it was not building things, it was enabling things and deciding where we were going to launch them. And the biggest part, obviously, was waiting for the backups to be restored in a different data center, because that just takes time. Around 9:10, what we initially thought at night, everything is fine, we looked at the monitoring, we actually realized we'd overlooked one customer. We'd overlooked a cluster that at first sight looked completely healthy, because yes, there was a node missing, but there was an underlying problem that we didn't detect in the middle of the chaos. So at that point, we decided to, hey, we're going to switch this to a one node, because all the data was still there. We switched this to a one node mount point, just mount it over NFS, and the application can continue working, because we had intermittent files that weren't actually being read. So don't try this at home, because the moment when you use Gluster as a direct file system, you're going to have troubles later. You're going to need to recopy and re-add all the files again so they're being touched, and that people know that they're being, well, the system knows that they've been touched again. So no data was lost. No customers were actually having trouble, and we were kind of happy. A couple of internal tools were being restored. We verified that all of the primary nodes that typically make the backups were now also, the backups were configured on the secondary node, so that in the evening, at night, we were actually taking backups again. We were verifying that we had sufficient disk space on those backup nodes to make the backups. And what we realized, well, you know the saying where the shoemaker always wears the worst shoes. Our customer platforms were quite good, but the problems we really had, the things where we really wasted time having to restore things and reprovision, was our own internal tools. our own Nextcloud, our own Redmine, not Redmine actually in this case, GitLab. And we also realized that we started to have a new challenge because we were not the only ones who had lost hardware. Everybody needed new hardware. So there was really like, we need to get replacements for this hardware. We really need to be able to spin it up, and OVH is not going to be the one who's going to give it fast to us. So we spun up hardware at a different supplier. We already had some things there, and we just moved things there. We did some wrong decisions on day 2 because we kind of had the idea to, what about we use a new supplier? What about you try to use one we've never played with? While that on a system level worked perfectly, we were spending time figuring out how we would do network redundancy and load balancing strategies with them right, and how we would be triggering failover. While we actually could just spin up things at suppliers we were already dealing with. So the third phase of that night was basically verifying if everything was back in place. Figuring out when the first announcements were coming, like what is going to come back? At what rate is it going to come back? How is it going to come back? Are you just going to turn it on, and are we going to see nodes pop up again? Or are they going to do it in a controlled way? If we have development and acceptance platforms that are now impacted, which ones do we really need to be back so that we can actually trigger our pipelines and that we can do our continuous delivery for those stacks again? And obviously, the hardware. What do we really need in this phase? The other thing we realized is, for that one customer where it was their DR site that was gone, we needed a new DR plan. We needed to figure out what we were going to do with them. So, putting in priorities on what was the hardest part, trying to anticipate on what we were going to get back at what point, which was initially, we're going to get this back by the end of the week. Then it became, well, some of it is not going to come back. And then eventually, some of the things came back in a totally unusual state, like a month later. But by then, we'd already, in our mind, decommissioned them. So we built a new plan for the DR site. The question at that moment is, do we need one now? Do we spin this up again already? Or are we going to assume and hope we don't get a double failure? Or, given that it's only partially impacted, is this sufficient for us for now? So one of our priorities actually was to respin that new DR site so that in case something else happened, we could do this. And I'll come back to why that was trivial for us. It's pretty much because how we use infrastructure as code. Why did we survive this? Why did we really have not that much impact? We've been saying this for a year in the DevOps movement, but automate all the things is really what saved us. We really use infrastructure as code. We really use everything under configuration management. We have desired state in place, and every single component of a stack is managed. While we see a lot of people out there who do infrastructure as code up to a way where they just provision something up to the operating system level, or even up to the middleware, but don't go into the application level and have different teams that need to come in and build the application on top of it. We basically spin up everything from scratch, and we automate it all the way till, like, if a box disappears, I spin it up again, it's going to be perfectly a part of the cluster, and it's going to work. So real infrastructure as code, our architecture, having backups, and really the fact that we responded to this really fast is what saved us. So we use Puppet. We've been using Puppet for managing those things. We can provision VMs, we can deploy applications, we can deploy database schemas, and it is one person who can do this. It is nobody else who needs to be involved. The automation is so that when we spin up a node, the load balancer is going to be reconfigured. The monitoring is going to be adapted. The databases are going to be clustered. It's really completely automated. And everything which has been in production for that environment is going to be exactly the same version when we spin it up. It's going to be deployed from our internal VM repositories. It's going to be certainly that it's going to be the same package it was before we lost the instance. And we do that through full automation. Everything is a pipeline. Our Puppet code base is a pipeline. Our Hera code base is a pipeline. DNS is a pipeline. Our Jenkins applications are a pipeline. So even our pipelines are pipelines. We do that also in a mindset where we are completely cloud native. We don't own hardware. We use bare metal on demand at a fraction of the price of what primary cloud providers like AWS charge. We use Hetzner, we use OVH, we use other suppliers, and we basically can spin up new hardware in 120 seconds, except in the middle of a fire, and decommission them when we need. Our VMs are defined in code. We typically use something like Ansible to bootstrap an instance, and then Puppet takes over and actually takes on desired state. We've been multi-cloud by origin. We use for every important stack multiple suppliers. And the deployment of that is identical. The workloads are flat. And when we have a customer that has a disaster recovery site, it's actually going to be with a different supplier. Within those different suppliers, we use multiple data centers. And we learned there now that we also need to have not only multiple data centers, but multiple campuses. And we really are completely cloud independent. Everything we build is built on top of open source components. It can crash. We build for failure. We can lose a bare metal server and it doesn't have impact. We can rebootstrap everything and only the user generated content is backed up. And all of this is built on top of open source tools. Everything critical for a customer is gonna be redundant. So yes, components can and will disappear from our setup. And we build it cloud agnostic. A VM is VM. It doesn't matter where it lives. It can live in a data center with a customer. It can live in the public cloud. It can live in any flavor of public cloud vendor. Whether we switch from one vendor to another one is figured out when we deploy it. Like how you deal with public IP addresses, how you deal with internal networking. Those are Puppet profiles that are being included based on the facts on where things are being deployed. So if we deploy an application stack in one supplier, say in OVH, and the next day we move it to, say, Hetzner, we don't have to change any code. It's going to be high available, it's going to have a different IP address, but it's still going to work. Typically, every stack we have is isolated specifically for that customer. Single-purpose VMs, single-purpose database cluster, single-purpose storage cluster, single-purpose load balancers. So if there is a problem, that problem is only going to be impacted for that specific project, for that specific customer. And everything is multi-data center. So even if a data center completely crashes, it's going to work. Obviously, what we learn now is that we need multi-campus data centers, if they are on the same campus and if they're close to each other, probably not going to work in the future. If we build things which are high available, that means we cannot use local files. If we have local files, we use cluster, or we still have the RBD clusters, which we're using to actually have active, passive, or in the cluster case, multi-active nodes. Every single of our MySQL setups is replicated. Our elastics are all backup, they're all multiple nodes, unless, of course, if they're just for performance, and then we can regenerate the data sets if we need them. And we also have multiple instances of our queuing systems and all of it. So everything we build is high available. Our VMs are on a local disk, which takes away the need of having a centralized file system to put the images on. And we can spin up those instances again because they're 100% perpetized. There's no difference in config when we spin them up. So we treat our VMs already as disposable. And for the other user data, it's either on application level or it's in a distributed storage system. And we do not use RAID for our VMs because all the data is already spread over multiple nodes on the network. Obviously, our backups are automated. They're part of every Puppet profile, and are always both on-site and on remote site, which is why we could restore so fast. Where lives their data? Documentation live. Well, our documentation lives in an mkdocs-based Git repository, which is typically hosted, accessible for everybody. But in the case of disaster, people can just run an mkdocs serve on the local copy of their documentation, which might be slightly out of date, but they have the local documentation. They have everything available which they need. So we did learn a couple of lessons. One of the things we were lucky with is that we still have spare material around, because if such a case happens, your supplier is going to at some point be short on hardware, and you might need more than they have available. So we could switch over fast. We had a little bit, and not that much, we had a little bit more resources available than we needed. We also knew that we could provision those resources on multiple providers. The other thing is obviously that a data center is not a data center. Even if it's different buildings on the same campus, you want to spread redundancy there. Obviously, you need to figure out what your customer wants to pay for, what value you want to put to it. But spreading it geographically over multiple cities, obviously, really important. The shoemaker problem is definitely one we need to fix. Internal services are often the ones you spend the least amount of time on, the least amount of priority, but they are still critical. If you depend on certain services in order to be able to spin up your infrastructure, you need to make sure that they're always available. Not something we learned, something I've known for close to 2 decades, is that it is a fucking DNS problem. We really want to have control over the DNS of all the production sites you run. Because if some third party is the only one who has access over that DNS, then you might be in trouble. And if it's not a DNS problem, it's potentially an NETWAYS problem in 2021. It was a long night. And I once again want to thank everybody who helped from the internal team, who helped to get that stack up and running again. After 8 hours, the 2 people who started went to bed and went to sleep and got a couple of hours of sleep and went back to figure out what the status was. But it really is a team effort to get this once implemented, but also recovered. We survived this because of our use of open source tools, because of our use of sane architectures, and because of thinking about how to deploy software and how to keep it running, even in this case. And I hope that you actually do the same, so that if the next time somebody calls and says, hey, my data center is on fire, you go like, yeah, it's only one data center. That's not really a big problem. Which is kind of what the state of our mind was after half an hour realizing it's only 3 data centers. So with that, this meme is now hot again. It worked on my machine, and it really was in fire. So thank you for your attention, and start a discussion.